Well, today we'll be doing SQL injection on TryHackMe. So without further ado, let's get straight into the box. So getting onto task one, it does ask for what is SQL injection. It just asks what does SQL stand for. So that's structured query language. Paste it in. Next up is theory stuff. So you should probably read it if you do not know what is database and answer these questions. The first one is what is the acronym for software that controls a database? So that's DBMS, that is Database Management System, and what's the name of a grid-like structure which holds the data? So I get that table. Moving on to what is SQL. This is also a theory part, but some of it is practical. It tells you what is the use of select command and other stuff. So you should read it if you do not know what is SQL. First thing is select. Let's say the first criteria we'll learn is the selector, which is used to retrieve data from the database. So if you have multiple databases and multiple tables in them, then after selecting a database, you can use select command to retrieve the stuff that is inside a table. So let's say we have a table named users, so we can do select all from users to get the data that is inside users table. So this just explains what's the use of select. Then also you can select stuff based on column name. So inside table we have columns. Here we had ID, username, and password. So we specified only username and password from users, and in the output you'll see only username and password. Limits the number of or number of stuff that you will see on the screen. It just limits the output to the specific number that you specify here. So if you say limit 1, so it will only output one result. So we have only one here. uh, Next up we have uh, the where clause. So this is used when you want to extract data specifically that belongs to a username. So here you'll say select all from users, so it selects all the users, and then it says where username equals to admin. So where the username is equals to admin, that data will be retrieved. So this stuff you'll see on the screen. Then we have where username is not equals to admin. So this is interrogation mark and equals to exclamation mark, sorry, exclamation mark equals to sign to specify not equals to. So whatever is so the usernames that are not equals to admin will be returned here. Next we have or. Here you'll see select all from users where username equals to admin or username equals to John. And so here the or is used to return the data whose username is either admin or John. So it just searches for either John or admin username. So this is a theory part, you'll understand it. Next up we have the percentage sign here. So this is the wildcard character in MySQL that is represented by a percent sign. So what it does is it's written over here that it just finds a match that either starts with or ends with the character that you type here. So if you type like a and then percent, so it will output all the data, all the usernames that start with a. It does not matter what is appended after, like it does not matter what comes after a. So it will just return every username that starts with a. Next we have like %n. So percent is here, so it will return every username that starts with any word, any character, but ends with n. So you'll see n here. Next up we have select all from users where username like this. So here the MySQL will search for username that starts with any character and ends with any character. It does not matter, but in middle it should have mi. It should have mi together. So we'll use the mi together here. So it returns this. Next up we have union. It's a broad concept. Union statement is used to combine the result of two or more select statements uh, that to retrieve data from either single or multiple tables. So with the select command, you can only output data in a table at once, but with the union, you can actually output the data of multiple tables at once. So you should read it. I'm not gonna read all of this. Next, this is the union use. So we have select name, address, city, postcode from customers with the union select of another table suppliers. Next, we have insert command. Insert command is used to insert the data inside an existing table. That is, insert into users table. In the username password field, it's inserting the values that are Bob and password 123. So you'll see the output here. Next, we have update command to update the existing data inside the table. So it's updating the users table, and it will set our username to root and password equals this, where username is admin. Next up, we have delete statement. An example you see here is delete from users where username equals to Martin. It's searching for the username Martin inside the users table, and it just deletes it. So you'll not see here. Then if you specify delete from users and not use the where to specify a single row, then all of the data inside the users will be deleted. So we have what SQL command is used to retrieve data. We have that is select. Then the SQL clause can be used to retrieve data from multiple tables. That is union. Then what SQL statement is used to add data? I guess that's insert. Perfect. Moving on to SQL injection. So what is SQL injection? Um, SQL injection is when a user provided data, that is user supplied input, will be appended into the SQL query, leading to SQL injection. So you can inject your own query into the existing query of the application. And here says, what does it look like? So you have a web URL, the website of THM, and blog page with the ID parameter that is equals to 1. So here you can change the ID parameter. There's a chance that you can inject your own SQL. You can check it by injecting apostrophe here. If it errors out, then there's probably a chance that you can execute your own SQL. And this here you'll see that select all from blog. So when you browse to this URL, this one ID equals to 1, the SQL query that is executing in the backend is this one that says select all from blog. Because the page is blog, so it selects all from the blog table where the ID equals to 1. So user supplied ID equals to 1, it's getting appended here, and private equals to 0, limit to 1. Here limit 1 is used, so it will only output one result. Now, if our user browse to the second page, that is ID equals to 2, and appends the ending statement with the comment, then the application's SQL query will end here, and the rest of the query that is after this end private equals to 0 limit 1 will be executed as a comment. So this query will not execute as it's a comment now, because you can append your own query here. Normally, applications which are not vulnerable to SQL injection do sanitize the user supplied input, but here, as it is a vulnerable machine, the user supplied input is not sanitized, which leads to SQL injection. You can see the semicolon in the URL signifies the end of the SQL statement, and the two dashes cause everything afterwards to be treated as a comment. Therefore, the query will be select all from blog where ID equals to 2, which will return the article with an ID of 2, whether it is set to public or not. So it could be private or public. So if it's private, then it will automatically execute output it. Then this was just one example of SQL injection vulnerability, which is called in-band SQL injection. There are total three types of SQL injection, that is in-band, blind, and out of band. So what character signifies the end of SQL query? That is semicolon. Now moving on to the practical part, we have a machine here. I'll just start it. And these are the explanations of three types of SQL injection. In-band is the easiest type to detect and exploit, uh, as it refers to the same method of communication being used to exploit the vulnerability, and also receives the result. For example, discovering an SQL injection vulnerability on a website page, just like uh, you see the same example in this machine. So you can whatever you input in the URL, you will see the output of that on the web page. So that is the easiest to exploit. That is what we call in-band SQL injection. Then the error-based SQL injection is the most useful for obtaining information about the database structure, as error messages from the database are printed directly to the browser screen. The output is not written to the browser screen, but the errors are returned. So with that, you know whether whether SQL command executed successfully or not. Then we have union-based. So this type of injection utilizes the union operator alongside a select statement to return additional results to the page. This is the most common way of extracting large amounts of data via an SQL injection vulnerability. I myself have used a lot of union-based SQL injection. I'm going to be using the split view here, just so that everything's on just a one screen. Zoom out a little bit. Okay. So the first step we have error-based SQLi here. Therefore, you can see the description here that says to discovering the error-based SQL injection, you need to break the SQL query by typing certain characters such as apostrophe or quotation mark. So we will do that here. This is the SQL query that is being executed right now. So instead of one, I do two. Then it will show two here. I press enter here, and then it says hope you like the updates to the website. I'll change it to 3. SQL query changes and result also changes. I change it to 0. It says no result found. Okay, so I'll change it to 1. This first article ID is 1. If I append an apostrophe here, the query should break, and it did break. So we did break the SQL query. Moving on, it tells us the same, that you will see this returns an SQL error informing you of an error in your syntax. So the fact that you have received this error message confirms the existence of an SQL injection vulnerability. We can exploit this vulnerability and use the error messages to learn about the database structure. The first thing we need to do is return data to the browser without displaying an error message. So for that, we will be using our union operator, so we can receive an extra result. Therefore, it tells us to append the union select to 1 after this. So I'll remove the apostrophe and I'll say union select to 1. I press enter, and it says the use select statement have a different number of columns. So um, the first step of exploiting SQLi, that SQL injection, is to find the number of columns in an application. To find the number of columns, you can just go on with the union select 1, then comma 2. If it still errors out, then keep increasing 1. And we do not have an error here. We have the usual web page here. That is my first article ID 1. All right. So this was the way of finding the number of columns. You can also use order by to find the number of column. You can say order by 1. It does not errors out. I do not know that is really on. Oh yeah, yeah. Order by 1, it does not error out. Order by 2 does not error out. 3 does not, and 4 on 4 it does errors out. It says unknown column 4. So by this error we know that there are 3 columns. So that is what we did with the union select. We just kept increasing 1 1 1 uh, manually. So uh, now I have to we have our first article here, and the data that it is fetching from the SQL query. uh, this is the data that we saw with the ID 1. So I'll say ID 0 so that we see 1 and 1 2 and 3 on this web page. I'll press enter, and you see it says 2 1 and 3. So instead of 1, if I say hello, uh, 1 2 and 3. Okay, this is being explained here. The error message has gone and the article is being displayed. But now we want to display our data instead of the article. The article is being displayed. The article was being displayed when the ID was 1. So because it takes the first return result somewhere in the website code and shows that, to get around that we need the first query to produce no result. That is why we change the article ID from 1 to 0. Okay, so now we can inject our own SQL query. The first query to know the database name in MySQL is to use database and then parentheses. This is a function of MySQL. You press enter and you will see the database name to be SQLi1. So we know that that database name is SQLi1. Now we will be looking for the tables inside this database, and and when we find the table names we will go with the column names. Okay, so for finding the table names we will be using the information schema, and you'll see that our next query will gather a list of tables that are in this specific database. So for that we will be using our group concat table name from information schema.tables, where table schema is SQLi1. So let me clear this out, and I'll say uh, instead of using a group concat for now, I'll just say table name. So table name, and then from information schema um, dot tables, where uh, table schema equals to SQLi1. So table schema, you can say it's just database name. So database name equals to SQLi1, and we press enter here, and you'll see article. Um, it's just this SQL query, this SQL query just returned one table name, the result, because we are not using the group concat function. To see all the tables that are in this database, you'll need to use the group concat function. So I'll say group concat and table name, press enter, and you see article and staff user. So group concat uh, gets the specified column, in our case that is table name, from multiple return rows and puts it inside one string separated by commas. So you'll see it separated the value by commas and put it in a single line. So we have two things here, that is article and staff users, and our objective is to find the Martin's password here. So here you see that we used information schema table, information schema database. This database is by default present on every system, and it stores the value, uh, and it stores the table names, column names of every database in MySQL. So with the help of this database you can actually fetch the table names and column names, and that is what we are doing right here. And to know, if you want to know more about information schema, then you should on your own go into your MySQL client and see the information schema table. I have not done it, but let's do it. Okay, so I'm inside the client. I'll say show databases, and here you'll see that I've created a database named school, and the rest three are by default. and we have information schema here. I'd say use information schema, and then show tables, and we have a number of tables here, and you'll see all plugins, and there are multiple so columns, and you'll see tables here. So we used the information schema dot tables, so it is specify the information schema database, and then dot tables specifies the table name inside the information schema database. So let's go inside the tables. Uh, let's say select all from, oops, yeah, from tables, and it outputs the tables of every database. It's a bit hard to read. Zoom out. You should try it on your own machine to understand it a way better. But I guess you got the idea of how it works. Yep. So we have the table names. Next, we need to fetch the column names. Following the same way, we will replace the table name with a column name. We'll say column underscore name from information schema. Instead of tables, we are fetching with a column, so we will replace that dot tables with columns. Where table schema, nope, we'll have to specify the table name here. So we'll say where table underscore name equals to the table name is staff users. We'll say staff users. You need to put this inside apostrophes, uh, inside comma, sorry. And we have three column names here inside the staff users table. So now it's pretty much straightforward. And yeah, so now we will be fetching the values inside these column names. And the same way is explained here, that the query results provide three columns, that is for staff users, that are ID, password, and username. We can use the username and password column for our following query to retrieve the user's information. So we'll again use group concat and username separated by the uh, colon and then password. And then we are using the separator br is used br is just like the enter key. You press enter key and you go to the next line, so br is used to go to the next line and from staff users. Okay. Doing same, so group concat, let's say username, and then if I do not separate it with the colon, let's see what happens. What I'm not going to use a separator tool. I just say from staff users. I press enter, and it just shows us an error. Oops. Oh, okay. Yeah. So we have admin password, Martin password, and Jimba123. So admin username and password are both appended together, so you do not know. It's a bit hard to read, so that is why we use uh, colon here to separate them. I press enter, and now it's a bit readable because it's separated, because both the values are separated by the colon. But still, we can also use the separator br to separate each username password value uh, with a new line. So we press enter, and you'll see that every value is a new line. So we have the Martin password here, that is this. We copy paste this, and we get in, and we have the flag here. Let's paste it in, and there we go. Now moving on to the task 6, blind SQL authentication bypass. So here, username and password login form, and our SQL query is right here. Let me copy my IP address and Go into the Kali machine, paste it in. Okay, much better. Let me close this split view. Okay. So blind SQLi is where we can see the results of our attack directly on the screen. Blind SQL is when we get little to no feedback to confirm whether our injected queries were in fact successful or not. This is because the error messages have been disabled. So you'll not see any kind of error messages in blind SQL, just like we did before in inbound SQLi. But still you can exploit the web app using the blind SQLi. So authentication bypass is a technique of blind SQL injection that is pretty much straightforward in login forms. We are not that much interested in retrieving data from the database in blind SQL. We just want to get past the login. So that is what we are going to do here. And uh, in blind SQL, we just need to create a database query that replies with a yes, that is true, or yeah, we need database query that results in true to know whether this stuff is true or not. You'll know. So let us go with the practical. Uh, the level 2 of the SQL injection explains how this example works, how this works, and we have this query here that says select all from users table, where username is equals to the username inserted by the user and password is equals to the password inserted by the user, and limits the value by 1. And the username and password here are taken from the login form fields. So this is a simple query, and this is really vulnerable because the user input is directly put inside the script query without sanitizing it. So therefore it's pretty much easy to exploit it. You can just use this thing easy payload, that is comma and then r 1 equals to 1, and then it ends the query and specifies everything as a comment. So let's see it practically. Alright, so we have username and password fields here. I input admin here and password here. I try to log in and this is no results found. So our SQL query is right now select all from users, where username equals to admin, it's taking the value from here, and password equals to password, taking the value from here, and limits the value by 1. So if a user goes on, uh, if I test here, you see that our value is inside the apostrophes, right? What we can do is insert apostrophe here, and it looks like our username is empty now, and whatever we input after it is the SQL query that we can execute. So instead of test here, I'll say or is a function, you know it now, and I'll say 1 equals to 1, and everything after it will be executed as a comment, sorry. So this is not valid now, this stuff. The only query that will execute is till here. So the query now says that to select all from users where username is blank, because there's no username, and or 1 equals to 1. So when 1 equals to 1 is true, and if one value is true, then the whole query returns out to be true. So if our SQL query is true, then we get past the login page. So I'll just say login. Oh, we have an error here, and that is because we did not end our SQL query. So we need to end our SQL query with a semicolon. I press login, and we get past the login. So he says you bypass the login and can move to the next level, level 3. Perfect. Let's copy this flag and paste it inside here. Great. Now moving on to task 7, this Boolean based. So Boolean based SQL injection refers to the response we receive back from our injection attempts, which could be true or false, yes or no, or 1 or 0, or any response, which only ever have two outcomes. The outcome confirms us that our SQL injection payload was either successful or not. So, for example, take this website that here you see check user page and then appending a username parameter whose value is admin. So the body browser contains the contents of taken true. The API endpoint replicates a common feature found in many sign-up forms, blah blah blah, and then because the taken value is set to true, we can assume the username admin is already registered. Okay, so looks like it's checking whether our username is registered already on the web page, web application or not. So it says taken true, which means the username admin is already registered. And we can confirm by changing the username in our address bar from admin to admin123. And upon pressing enter, you'll see that the value taken has now changed to false, which means that this username does not exist. So this is the SQL query that is being processed here, which says select all from users table, where username is the username we input and limit the value by 1. And here the only control we have is on the username field. So we will have to use this to perform our SQL injection, keeping the username as admin123. We can start appending to this and try to make the database confirm two things, which will change the state of the taken field from false to true. So this is a bit of theory part. We will move on to practical, then you will start to understand things. And like in previous levels, our first task was to establish the number of columns, as I told you before. So we can achieve this by using the union statement. Change the username value to the following. It says change it to union select 1. Web application has responded with the value taken as false. So we can confirm this is incorrect. So whenever the application returns true, then we know that yeah, these are the number of columns in the web application. So once we use 1, 2, and 3, we specify 3 columns. The web application will return true if it does contain 3 columns. So it looks like it did, and we can now work on the enumeration of the database. The first task, as always, is to find the database name. And in MySQL, there's a function called database parentheses method by which you can uh, uh, know the database name that is being used currently. So here we used union select 1 to 3, and then where database uh, it says database and then like percent. So suppose the database name is SQLi, then this query will return true because it's searching for the database name. If database name is like any character, so the percent here specifies any character that you see on your keyboard. It could be A to Z and any percent sign, underscore, anything. So it says yeah, it does, it starts with the whatever the character is because we specified any character. So the SQLi says yes, the database name starts with any character. So we get a true response because in the like operator we have used the value of percent, which will match anything as it's the wildcard value. So if we change the wildcard value operator to a%, you will see the response goes back to false because the database name starts with the S, and you're saying that does the S database name starts with A? So the SQL says no, it does not start with A, so it will return false there. So which confirms the database name does not begin with the letter A. So with this way, we can cycle through all the letters, numbers, and characters such as dash or underscore until we discover a match. So if you send the below as a username value, this one as percent, it will say true because the database name does start with S because our database name here is SQLi3. Therefore, for example, if you say as a%, then it will return false because the database name does not start with S and A, it starts with S and Q. Therefore, you keep appending, therefore you keep changing the character unless you find a true response. So if you say SQ%, it will return true because the database name does starts with SQ and ends with any character. And by this way, we find the database name to be SQLi3, and then with this information, we go on forward to finding the table names with the same format with the help of this wildcard. So the rest everything is same. We are just using this like and this percent sign. All right. So now we have to use moving on to the practical part. I'll open the split view here. Okay, so here's our website, and okay, so as usual, our first step is to find the number of columns. So with the admin username to be admin123, it says taken false. We need to set the taken to false right now because we will be appending our payload here, which we need to know if that is true. So if that value will be true, then this should also be true, which will tell us that yeah, the database starts with this character and the table name starts with this character, and so you can enumerate the database name and table names. So here I'll say uh, unions. Wait a second. First, I need to close the username because you see the SQL query here. Username, I just appended the apostrophe. Our username admin123 has closed now, and whatever we input after here will be appended after the query. So after the username parameter, sorry. So we have username select. I say one. I close the query, and rest of that will be the comment. I press enter. It says false. I append two of the two columns. It says false. I 1 to 3, it says true. Yeah, so there are three columns. Perfect. So if I say here, uh, I say where database, well, now we are trying to find the database name. So I'll say union select where database like, uh, I'll say does it start with S, the person, and it says yeah, it does start with S. And if I enter A here, it says false. It does not start with A. I say B, does not. I say Q, yeah, it starts with Q. So it will take a lot of time. So I'll just say does it starts with SQLi. Uh, Free, it's a yeah, it is. So if I enter any character here, it says false, false, false. Okay. So I remove this character now. It says true. Yeah. So here we know that the database name is SQLi3. And mm, once we know the database name, we'll go on to enumerate our the table names. We have a payload here that says you select 23 from information schema.table, where table schema is SQLi3. So this query is pretty much same as we use in inbound SQLi. So I just paste it in, and then it says and table name like this. Uh, so actually, uh, it's asking the SQLi, it's asking the MySQL whether the table name starts with a A. It is false. It does not start with A. We say does it starts with B. It says false. So if you keep doing that, you'll come to know that the table name starts with character U, and you'll come to know that the table name is users here. So I'll just paste it in for saving some time. It says yeah, the table name starts with the table name is users. Okay. Following the same pattern, you can fetch the column names. Information schema dot columns. So here table schema is SQLi3, and table name is users, and the column name like a person. So it's the same format. So following with the same format, you can also find the column names. Next, once we know the column name, we'll say select from users table where username uh, starts with A. So here doing the same thing, we are fetching for the we are fetching the data. Uh, if we are fetching the entries that starts, we are fetching the username entries that starts with A. So it says that yeah, this query was returned out to be true because the admin username exists on the database. So if you keep doing this, then you'll come to know that the username admin does exist. So once we have got the username, we can concentrate on discovering the password. Therefore our payload will for finding the password will be this, which is union select from users where username is admin and password like a%, just the same format. So cycling through all the characters, you'll discover the password is 3845. So once we have the username and password, we'll just enter here. We'll say admin and the 3845. We log in and we do get in. So let's paste it here, the flag here, and we move on to our next task 8, that is blind SQLi. That is time based. So the time based is where you do not see any output, but you can execute this some commands there. So time based blind SQL injection is very similar to the Boolean based. In the same in that the same requests are sent, but there is no visual indicator of your queries. So instead, we our indicator of a correct query is based on the time the query takes to complete. So this is done by using sleep function. So the time delay is introduced by using built-in methods such as sleep alongside the union statement. The sleep method will only get executed upon a successful union select statement. So if your statement was successful, the sleep command will execute, which tells us that if we see the response in 5 seconds, then it tells us yeah, our command got executed successfully. But if you do not see the response in 5 seconds or whatever the time you specify, then you know that your query was false, that it did not execute it. So for example, when trying to establish the number of columns in a table, uh, as our first step as usual is find the number of columns. So for finding the number of columns in the table, we will use the following query. So admin23 union select sleep 5. So if there was no pause in the response time, we know that the query was unsuccessful. So we will keep appending more columns here. So we'll say does it have two columns, because our first column contains this and the second column contains this. So this payload should have produced a 5-second time delay, which confirms the successful execution of the union statement and also confirms that there are two columns. So let's try using it. I'll copy this and paste it here, and I'll remove this tryhackme.com. Yeah, I press enter and you see that it's taking its time, and request time should be 5 seconds, and it is 5 seconds. That confirms us that it does contain two columns. So if I remove this, so I'm saying does contain only one column, and it's a the response request time is 0. Our sleep did not execute, which confirms that our query was false, so it does not contain one column. So now we know that it contains two columns. We can move on with the same enumeration process of Boolean-based SQL injection, adding the sleep method into the union select statement. So it the commands will be same like above in the Boolean-based. In the blind SQL, like just so our commands will be the so our payloads will be the same, just like we saw in our previous task. So I'll just go straight forward with the payload here. So it says union select sleep 5, where database name is like you. So it's asking whether the database name starts with you. So I'll copy this, paste it in, press enter, and it says that no, that database name does not starts with you. So database name here does starts with s, because if you type s, then request will take 5 seconds to execute. That confirms us that yeah, the database name starts with s. One thing to note here that I'm not going to uh, append one character every time, as it's gonna take eternity. So I know the database name here. I'll say SQLi underscore. I guess it's 4 maybe. And you see it's taking its time. So yeah, that confirms that SQLi 4 is the valid database name. Perfect. So now once we know the database name, we'll go on finding the table names. So using our previous payload that was in Boolean based blind SQLi, um, you see the same payload here. So let's say from oops yeah, yeah from information schema dot tables, uh, where table schema is equals to SQLi 4, as this is our database name, and table name. Now I am asking SQLi whether the table name starts with the U, and person sign here, and end the query and append the comments, press enter, and looks like the request time should be 5 here, and yeah, request time is 5. So that confirms us that our table name does starts with U. So U should stand, I guess it's user. I'll straightforward ask it if it's user, press enter, and it says no, the table name is not user. So maybe it's a username. It says no, maybe it's username. It's a no. Okay, so I guess it's users, just like our previous task. In our previous task, the table name was users, and it's the same here too. Request time is 5. That confirms us that yeah, the table name is users. So you can keep doing this and find the column names too. The column names are also same here: ID, username, and password. So I'll go straight forward, finding the password of admin username. So it says from information schema dot tables. Nope, I do not want this. Yeah, so union select sleep from users where username, oops, yeah, where username equals admin and password like A, run the query, append comments, and our password doesn't start with A. It starts with B, nope. C, nope. So you need to just keep doing it and then unless you find the password. So actually I kept enumerating, and once I appended 4, I said that the password starts with 4, and the query returned okay after 5 seconds. So we know that yeah, the password starts with 4. So in the same way we can keep enumerating it. So I'll skip this part and I'll see you around when I find the password. Alright, so I looks like I found the password to be 49601. So I'll say admin and 49601. Press say login and training complete. We have our flag here. Oh, I've already submitted it. Okay. Oh, okay. I was in the wrong task. Okay. So moving on to the task 9. We have our out of band SQL injection. This one is not common as it depends on specific features enabled on database server or the application's business logic. Mm, so out of band attack is classified by having two different communication channels. One is to launch the attack and other is to gather the results. So for example, the attack channel could be web request or data gathering channel, could be the DNS or HTTP request made to services you control or your own server. So the attacker makes a request to a website vulnerable to SQL injection with an injection payload. The website makes a SQL query to the database, which also passes the hacker's payload. And then the payload contains a request which forces an HTTP request back to the hacker's machine containing data from the database. So actually, in this method, we are redirecting the output uh, that we get from the query to our own server that we host. So it is asking the protocol ping name D that can be used to exfiltrate data from the database, that is DNS. And that's done. We have the remediation tips here, that is input validation and escaping user input, that is also known as sanitization. So it says name a method for protecting yourself from SQL injection exploit. So I guess that's to prepare the statements. These are the most famous ones. And yeah, correct answer. So this was it for this time. I hate these tricky phrases. I tried my best to explain the things in detail, but yeah, I know this was my first time explaining a whole room, and there were some things that I uh, messed up, but I hope you understood. Uh, See you next time. Bye bye.